All right. Good afternoon, good morning, wherever you guys happen to be listening in the world. Thank you so much for tuning in. Really looking forward to today's conversation. I'm joined today with, of course, Dr. Deepthi Agrawal and Dr. Joseph Raphael, who is a real expert in precision medicine, really one of the pioneers in this field that a lot of us are building on top of. And he has a particular domain of expertise related to inflammation and how it relates to aging. And he makes use of a very interesting test called glycanage, which uses a process called protein glycation, or measures a process called protein glycation to understand the aging process through the lens of inflammation. And so a lot of us hear about, oh, you got to reduce your inflammation. It's going to slow down aging. It's going to make you feel better. I think very few people actually understand how to properly measure it, right? Like we have very coarse tools like CRP and whatnot, but there's a layer deeper that we can go, as Dr. Raphael will show us. And I think the second part is like what to actually do about it therapeutically. And you might be surprised by some of the therapies that move the needle most on reducing inflammation. Before we get into that, I just want to make a quick plug for our conference, which if you're listening to this, you should definitely apply to attend. Deepthi and I are hosting the Next Generation Longevity Summit in Osaka, Japan. This is going to be an absolutely incredible gathering. We have some of the top academics, scientists, clinicians in the world joining us. Unfortunately, Dr. Raphael is not one of those people, but he's still a top clinician for sure. But we have Dr. Eric Verdin, Dr. Brian Kennedy, and others. You can check out our website, nextgenerationlongevity.com. It is application only, but if you're listening to this on LinkedIn, you probably are somebody who should be there. And so encourage you guys to go to the website. I'll just pop it up real quick here. Please apply, sign up. We'd love to see you there. All right, so with that, let me turn it over to you, Dr. Raphael. Go ahead. Thank you so much for joining us. And I guess just to start us off, tell us a little bit about how you think about inflammation as a process, and how have you over the years kind of measured it, and how have you seen it affect aging in your practice?
So inflammation is one of the most important processes in the aging process. That's why this LinkedIn Live is called Inflammaging, because Claudio Franceschi, one of the premier researchers in inflammation and in immune aging, coined the term around 2000, because what happens with the chronic diseases of aging is often very much driven by chronic low-grade inflammation. And you want to sort of separate out inflammation from inflammaging. Inflammation is not a bad thing. That's how the immune system works. You have an acute infectious insult. You want to mobilize the immune system, have a response of inflammation or a wound, whatever it is, and then resolve that inflammation, that infection, and then the inflammation should resolve. Inflammaging is when there is a lack of resolution of that, and there is a chronic low-grade inflammation that is simmering in the background as we get older, driven by many things: chronic viral infections, oxidative stress, toxins, lower hormone levels, accumulation of senescent cells and the secretory phenotype that they secrete. All of those things is this low-grade chronic inflammation that drives many processes of aging. And so, when I think about aging and the immune system, you want to not think simplistically about it. You don't want to just suppress all inflammation. You want to make sure the immune system can do its job, get in there, and then go back to a quiet, uninflamed state.
I think so. Joe, I want to take us one step back, because I don't think a lot of people appreciate, that you've been following the evolution of aging biology, telomere science for many years. And also you have a very boutique niche clinic, and you practice in a very progressive and creative way, but with scientific backing for all of these years. And so maybe you can start to even just tell the audience what what's changed in your own thinking about how people age over the years, and how that's come from just tracking aging biology in general. And then even before from there, if we can even just start for people in the audience who might not even know what the term glycan is, so that we can actually talk a little bit more about the test and Inflammaging in general.
Yeah, so let me give you a little context. I've been doing this for over 25 years now, and one of the major reasons that I am very interested in aging, and in particularly biomarkers of aging, is because Robert Butler, the founder, and the late Robert Butler, founder of the National Institute of Aging, at a roundtable I went to, said to me, Joe, it sounds like your patients are doing well, they're feeling better, but how can you call yourself, back then we called ourselves anti-aging physicians, if you don't really know how to measure aging? And that set me on a long and continuing sort of passion of mine to understand the aging process through measuring aspects of it. And one of the major things that we were doing early on in the field was looking for a biomarker, the biomarker of aging. So, what is your biological age? And what I've come to understand over the years, and I think the field has moved in that direction as well, is that there is no single biomarker of aging, biological age, that you can say you are, and it's not really that useful, because aging is a process that takes place at many different levels, in many different systems, and it's asynchronous, really, within individuals and between individuals. So your liver, your lungs, your arteries could be aging at different rates. You could have a really elastic arterial system, but be sort of metabolically inflamed. Your telomeres could be kind of short, but you're still doing okay. Your cognitive function could be good, or your immune system could be good, but some other system is not doing as well. So I think of aging really as a mosaic within individuals and between individuals. And to give it one number is not that useful. We got seduced by the epigenetic clocks because they predicted chronological age so well, like an R squared of 0.98 or something like that, that we thought that was the number that we should focus on. But really, that's just one aspect of things. And so you want to look at aging from many different standpoints, which is not to say that there aren't processes that affect each of those organ systems, even though they're aging asynchronously. And inflammation is one of those, and telomere reserve is one of those, hormone levels are one of those things. So there are things that cross the organ systems and I think inflammation is a major one. And so that's sort of where I've gotten to. I think the more angles you get on aging, both between organ systems, but also molecular, cellular, the multi-omics that have been very hot now, proteomics, epigenetics, and glycomics, which we're going to talk about in detail. Those are all great, but then you also have to make sure that you're not losing sight of the very tried and true physiologic markers like arterial stiffness, pulmonary function by FEV1, VO2 max, grip strength, all those things that are functional markers, cognitive tests. Yeah, I can look at p-Tau 217 to see what your risk of Alzheimer's disease is in the next 3 to 5 years. But you want to know, how fast you can process things, your simple digit coding speeds, your reaction time, your verbal and visual memory. So the more information you get on the patient, the better. And then the point of it is, of course, to do something with it. And so you want to find something that you can look at the trajectory, start a therapy, and see if that trajectory is being moved in that biomarker. That can cross over into other ones, but you want to assess, treat, reassess, monitor, and continue that process. And that's what longevity medicine is. That's what precision medicine is.
Got it. So let's kind of get into kind of the crux of the thesis here. So we've talked several times about glycation. Can you tell us more what that is and how it relates to inflammation?
So let me just say that
glycosylation.
Yeah. So it's a very common thing, and I think that's why I should bring it up. Glycation is different from glycosylation.
Yes.
Glycosylation is the bigger mouthful, and glycation is what happens when it's a random process of damage where glucose gets attached to proteins, like hemoglobin A1C. Glycosylation, on the other hand, is a regulated enzymatic process in which other types of sugars, not glucose, and strings of sugars get attached to proteins, lipids, and alter their function. It's really the fourth revolution in evolution for signaling. You have DNA to RNA, RNA to proteins, and now we have proteins getting post-translationally modified with the addition of sugars, galactose, sialic acid, fucose, that profoundly alters their function. And it's really the way in which humans, or mammals, but particularly humans, which have 30,000 genes, and an amoeba, which can have, or a yeast can have even more genes, can have much more complex phenotype because of these alterations in proteins that take place. That is through glycosylation. And we're going to talk particularly about the immune system today, but it occurs on other proteins and lipids as well.
So then,
go ahead.
Go ahead. If you were finish your thought.
Yeah. Well, so I was just going to say that just the take-home message is glycation's bad. That's what happens in diabetes, advanced glycation end products, hemoglobin A1C being sort of the paradigmatic one that we think about. Glycosylation, not necessarily good or bad. It's the process in which proteins get modified after they are created and then released, before they're released into the system, that alters their function profoundly to make them responsive to the environment, to medications, to stresses, etc. It's literally the fourth signaling mechanism.
So, and I just want to be able to break this down for people who might not understand. So can we talk about what IgG is and what it has to do with the immune system, and that what does glycosylation, like that pattern of the IgG, how does that relate to inflammation? Great.
Yeah. So the IgG antibody is the most abundant antibody circulating in your blood. I mean, you do things like find out what your COVID antibodies are like. That's an IgG antibody, and it is part of the adaptive immune system, the humoral part. Then there's the cellular part. The humoral part is the antibodies are made by the B cells and plasma cells. They're released, and they have a structure that we're all probably familiar with, which is that Y. There's the two arms that can then recognize the antigen, the part of the virus or bacteria that is uniquely designed to recognize. And then the bottom part, the stem, is that's called the FC. The FAB is the two antenna. The FC is the portion that then takes the signal that is picked up by the antigen recognition and then turns it into how it communicates with the immune system. So the FC receptor communicates with complement and with other cells of the immune system that are effector molecules, and tells them to go attack this particular antigen. And what happens with glycosylation is that once the antibody is produced, it then has, before it's released from the cell, these sugars added to it that are under the control of these glycosyltransferases, these enzymes that will add to this particularly conserved spot. It's on the arm called asparagine 297, and they add either different types of sugars. So it can have, if we can get to the glycan age test, and well, before we do that, that then changes the whole kind of shape of the. Did I lose you guys? No, I didn't, because I'm still the one speaking. Sorry. So that alters the shape of the antibody and how it responds. It can alter how it responds to the antigen, but particularly how it interacts with the immune system, the cells of the immune system. So some patterns can make it more inflammatory, other patterns can make it less inflammatory, and some patterns are sort of more neutral. And what determines that is the sequence of sugars that are attached. They all have 3 mannoses sitting on them, and then they have attached to them either 2 galactoses or, 2 mannoses and often a fucose, and then they have galactoses attached to them. And then on top of the galactoses, they can have something called sialic acid attached to them. And why that's important is because the glycan age test looks at these 3 different types of glycans that they get, and they can be what's called the glycan shield, which is the one with the 3 layers and has the 2 sialic acids, or at least one attached to it, very anti-inflammatory, and occur very much when you're young. But particularly the second one, which is called glycan youth, which is having 2 galactoses, those make it less engaging with the FC receptor, so it doesn't turn on the effector molecules, effector cells as much. And then if they're missing them, galactoses completely, it's called glycan mature. And it's called glycan mature because that happens when you get older or when you lose hormones, or it also makes you more susceptible to autoimmunity. So those are the 3 kind of different subspecies that you get when you get a glycan age test and when they're looking at these sort of things. And what happened was that in 2014, they did a study with 5,000 subjects in multiple cohorts, and they looked at these patterns. And 21 of these glycan peaks out of 26 were associated with aging. And what they were able to do was to come up with an algorithm that used those 3 different glycan subspecies to predict chronological age. And it predicted it pretty well, like at an R squared of about 0.6, 0.58, which is nothing like the methylation clocks, which is 0.9, 0.98. But that's okay because subsequent studies show that it's much more predictive of other things that we're more concerned about than predicting chronological age, which we can do just by looking at your driver's license. And so that is what the basis of the glycan age test is. And just to go back a step, what they do with the assay is they get a dried blood spot on the test, and then they take that and they digest the glycans off of the antibodies, and then they run it through high performance chromatography, and then they separate it out, and they can know which of the different kinds of sugar combinations are in that sample. And that sample is not like a CRP molecule or IL-6 or something like that, or CRP. It is a profile of all the different glycans attached to all your circulating IgG antibodies. So it's a broad readout of what's happening at that time, the state of your IgG population floating around in your body.
So
Okay,
super interesting. I think one thing that is new to me is this idea that, what determines the immune response is not just how many antibodies you make, so to speak, but also how they're post-translationally modified. That actually determines their activity. Super interesting. I guess just to kind of double click on one of the questions you touched on, and I'm sure this is what a lot of our audience is wondering, is around what information does this add about inflammation, that IL-6, C-reactive protein, fibrinogen, these other markers that we're often measuring, like, is this kind of like a broader measure that covers inflammation in a more comprehensive way that these don't? And I guess the related question would be, is there something we can get out of this reading that can help us understand more specifically what is going on within the inflammatory process? Because it's kind of like a broad term to say, oh, there's inflammation. It could be any number of different signaling pathways kind of dysregulated. So is there anything that gives us specificity as well with this?
Yeah, that's a great question. I mean, people ask me about this all the time because they're like, well, I have a CRP already on my patient. I have an IL-6 on my patient if they're a little more sophisticated. I have a fibrinogen, I have a ferritin. What is that adding? So those are single molecules that, and particularly CRP is very responsive to acute inflammatory situations, an infection, if they have a flu or something like that, or if they've really exercised super vigorously and there's been some inflammation in their body. Same with IL-6. IL-6 is sort of what the precursor to causing CRP to be produced. And ferritin is there. It's the caveat on that is if you're iron deficient, then your ferritin can be low even if you're in the state of inflammation. It is an acute phase reactant. So those all give information, but what's sort of unique and I think really useful about the IgG glycosylation profile is that it takes about 3 weeks for an antibody to turn over, and then so maybe about 3 months for a number of cycles of antibodies to turn over, so that you get a different population depending on if there is something going on. So you get a better readout of sort of the chronic state of over the last 3 or 4 months of what your immune system is doing from a humoral antibody standpoint. Now, that's not the whole immune system. There are many other factors. There's accumulation of senescent T cells, which is a very big factor as well. There's chronic viral infections. There's the innate immune system, but the humoral immune system and the IgG glycosylation does control like how much complement gets activated, how much your antibody-dependent cytotoxicity gets activated, many other aspects of chronic inflammation. So it is a good readout of what's been happening over the past 3 months, but it's also not susceptible to short-term perturbations. I kind of think of it, and this is, of course, again, not to be confused with glycation versus glycosylation, but I think of it as sort of a hemoglobin A1C for inflammation, just like A1C is for chronic glucose, whereas CRP elevation might be like a glucose level that you get. It's a more short-term measure. And so when you do something to change it, things like losing weight, particularly visceral fat, reducing stress, getting rid of chronic infections, when you remove those, you want to see a change in the glycan age over that next 3 months. And then if you see that it hasn't changed over a year, then you've got a pretty stable readout of what's been going on from overall immune function. And which we'll talk about a little bit more, that has been associated with many other outcomes in chronic disease states.
If we try to make this a little bit more practical now that we've talked about the science. So if a healthy, quote unquote, someone that thinks that they're relatively healthy, so let's say 40 years old, walks into your office, what would they expect to learn about themselves from a glycan age test?
That's a great question. And when, the question is, we have a lot of different tests at our disposal. Why should we get one test versus another test? What's it going to tell me if I get this test that the other tests that I'm doing aren't telling me? So no one's completely healthy. There's usually, everybody's got, like I said, a mosaic. Some systems are functioning at a level much older than the chronological age. Some are much higher, much younger. And so what the glycan age helps you do is to figure out if let's say you come in and you're 40 and your readout is 50. The first thing I would say to the patient is that does not mean that you are biologically 50 years old. Okay? Don't think that way about it. What it's saying is that your IgG glycosylation pattern, your glycan pattern on your IgG antibodies is most similar to the reference population of 50-year-olds. Now, that's not a great thing. You would rather it be 40 or younger. But then if this is a very healthy person and has no symptoms or anything like that, then I might want to start looking for things that we know are associated with a higher glycan age relative to your chronological age. And those are some of the things I've mentioned. Chronic inflammatory state. Do they have a wisdom tooth or an abscess in their mouth that's smoldering that they didn't know about because it's really kind of asymptomatic? Now, CRP may pick that up as well, but that particular example, it could be something like that. But sometimes CRP isn't even going to pick that up. But more commonly, this healthy 40-year-old may have a little bit more visceral fat, even though they're not overweight. And why do they have visceral fat? Because they're not exercising, they don't have as much muscle, they're not weak, but they have an early insulin resistance. And so these things are picked up by the glycan age test. A particularly important contributor to that could be that they have low testosterone, because low testosterone, through its conversion to estradiol, so having then low estradiol, can cause you to have a higher glycan age, and that can unmask a relatively low testosterone level that, sometimes patients come in and go, I'm pretty healthy, and loss of libido and loss of sort of vigor and that kind of stuff is insidious, and they don't really complain about it. But they make me, I get testosterone on everybody at baseline anyhow, but let's say they haven't had one. If you have a glycan age, and it particularly shows that the mature component is hot, you want the mature to be low, because you don't want to have a lot of them, because that means you have a lot of agalactosylated, no galactosis, so more inflammatory. If it's high, the mature is high, then I would get a testosterone level and see if their testosterone level is maybe not below 300, but it could be 400, and it's not converting enough to estrogen, and we're not getting enough of a signal to keep those IgG glycans with a more anti-inflammatory profile than a pro-inflammatory profile. Just to go back to that for a second, estradiol does regulate one of the major enzymes that it's called B4-GALT1 that puts the galactoses post-translationally onto IgG antibodies. So there's a couple other estrogen responsive ones, but that's why I think it's helpful. To know that. Now, let's say you get one that's 10 years younger. You're like, well, that's great. And patients never ask questions about that. You're like, okay, fine. I'm good with that. But that doesn't mean that you are, 30. It means that right now your pattern is more like a 30-year-old. Let's try to preserve that. And if it starts to drift up with subsequent tests, then we have a good baseline to know that that's a problem. And we're seeing a trend. Everything in precision medicine and longevity medicine, you get information from a snapshot, a single test, but longevity requires tracking trajectory. And that's where these tests really become useful, because they're fairly stable if the situation doesn't change physiologically. My glycan age has been within 3 years of itself for the last 6 years. And you're smiling because I'm not going to tell you how low it is.
Yeah, well, you're clearly not aging both visually, I'll say, and mentally, certainly. And then just doing the math off what you just said, it sounds like you're doing a lot of things right for yourself.
I am, but like my lungs are older. That's my weak system. Maybe because I smoked when I was younger. Maybe my genetic. I have a mosaic as well. And that's why I am addressing those systems. One of the reasons why mine is so low for the glycan age is because I've been on long-term hormone optimization, and I do all the other things: exercise, keeping body composition in good range, stress reduction, not as much as I'd like to, but I'm working on that.
So can we just double-click on something you just mentioned, which I think is super interesting? I know you and I have talked about this, Deepthi. You touched on the fact that hormone replacement therapy, testosterone, estrogen, has a profound effect on this. Can you use this test to titrate HRT or TRT?
Yes. So I would put that in the category of, I think that is something that we will be doing, but we don't yet have clinical trial evidence to say that isn't a completely evidence-based thing. Do I do that in my practice? I'm starting to, because of how important I think it is to keep inflammation low from this IgG glycosylation standpoint. When you adjust hormone therapy, you should, as a clinician, adjust it never from a single number, never from just a lab test, and I think the most important thing is now, particularly with regard to hormone therapy, is not just from a symptom standpoint either. And so that gets to your question. For a long time, we were like, for symptoms only, treat with the lowest possible dose for the shortest period of time. And I think that's thinking of hormones as particularly estrogen and HRT and testosterone and male hormone therapy as just a symptom-based therapy. And I think of it, hormone therapy for both men and women, as whole body system optimizing, regulating molecules, and you want to look at all of those systems. And so I think the future will potentially have in it where, even though the hot flashes are gone, the vaginal dryness is gone, they're thinking pretty clearly, there's energy level is good, but the glycan age is still 5, 10 years older. Should we perhaps alter it, the hormone therapy? Well, mainly we would do it if the glycan mature is still pretty high, because that's the one that's most estrogen responsive. And I have done that in some patients. Now, I don't think that that's yet at the general guideline standpoint, but I think that is something we're going to see in the future. And I hope that, and I think the clinical trials will be done at some point. I should just say as an aside, the damage of the Women's Health Initiative has been, getting undone over the last 25 years or so, but it's still not completely undone. And there is so much more research that needs to be done on how to optimize hormone therapy, route of administration, timing, cyclical versus non-cyclical, all sorts of things that I hope now start to get funded so that we can understand what's the best way to optimize it in a precision medicine way, in an evidence-based way. But I think that IgG glycosylation, because of its profound, how it's profoundly affected by hormone therapy, will be part of that calculus.
So 2 questions. So what other things are you seeing move the needle then for the test? Like, one that you present a lot of data on is hormones. Is there anything else that would be?
Yeah, for sure. In younger, the younger, like the 40-year-old male, it is things like visceral adiposity. It is chronic stress, emotional stress, high cortisol levels. We don't have the direct link yet, but probably something along those lines. Bad habits, smoking, lack of exercise, which brings me to, exercise, which I think is, being sedentary, you're not going to have as good a glycan age as you could have. Exercise is one of those things where, people say, traditionally, go exercise. And that's better than, not exercising. But exercise is something that needs to be dosed just as anything else needs to be dosed. And regular, sort of zone 2 type exercise, definitely, regular exercisers in studies, like 55 to 75-year-old exercisers have glycan ages that are similar to those who are, younger. But if you exercise too much, and you also have an energy deficit, so like the female athlete triad, where they're expending a lot of calories, not taking in enough calories, and they also have suppression of hormones, so their estradiol goes down, you can see the glycan age go up quite a bit. Whereas in like a study of 29 young males exercising, doing sprint interval training, they actually, even though it's high intensity, because there's an adequate recovery, their G0 population decreases, which is the no galactoses, and their G2 population goes up. So if they did a glycan age on them, it wasn't done on that study, but it would have gone up. So making sure you get enough recovery, making sure you get enough exercise, and have enough calories is important. And all of those things impact your glycan age.
Well, to your point, someone wrote on my LinkedIn that they have these friends that are young and have perfect biomarkers, but that they're athletes, but their glycan age is coming up to be 80. So that begs the question. And who knows if that was an exaggeration, but that begs the question, though, right? Where maybe you're inflammaging your body by the amount of extreme athleticism too, because there's always a Goldilocks, Goldilocks area for all of these values and also for all of our activities in general. Golden mean.
Yeah, I mean, that's absolutely true. I mean, 80 would probably, I've never seen anything like that. And I have some pretty crazy athletes, depending on how young they are. It's really the delta that matters. I mean, you could be 80 if you're 60, but if you're 80 and you're 40. 25, that's pretty unusual. But that's really where it's a good gauge, because some people can, like I'm thinking of Ross Edgley. I don't know if you know him. He's the super endurance athlete who's, just training like a maniac, and he does recover. And I've had other, you hear about other people that do a marathon a week and stuff like that. And those may have very high glycan age, although some people may have genetically, for various reasons, the ability to tolerate that. A glycan age would probably gauge that. Again, not randomized control trial data on that, but that's the kind of information you get. And we know that these species are important. They're, it's not just a marker. These are effectors of activating the immune system through complement and antibody-dependent cytotoxicity and other aspects of the immune system. So that, if you have a high level of these pro-inflammatory species, the agalactosylated ones, then you're not in as good a state of your immune system as you could be. And there's things to do about that.
Right. So if for our skeptical colleagues out there, where would you say that the data or evidence is still thin?
I think what we don't, I don't know if it's that much thinner than a lot of the other sort of cutting edge biological clocks that we're using let's compare it to epigenetics for straight up mortality prediction, a grim age, or the second and third generation clocks have a little bit more data, although the glycan age data is increasing. Let's be specific here, not for the actual glycan age readout number that we get in the glycan age test, but there are a couple of studies published recently looking at 4 different species of glycans that overlap with the ones in the glycan age test that predict future cardiovascular events with a hazard ratio of like 2.0, which is in the range of the epigenetic tests, the best ones but that you can't, it's kind of apples to oranges. All-cause mortality is a little different from cardiovascular disease. So I think there need to be some more longer-term trials. They're producing data all the time, and Gordon Louse is the major researcher in their lab. Genos is producing studies in collaboration with multiple other groups on biobank samples, particularly the UK Biobank, looking at predicting autoimmune disorders. A great paper by Shunikova, forget the year, where it shows all the studies that indicate where glycan species can predict autoimmunity, inflammatory bowel disease, metabolic disease, cardiovascular disease, hypertension, prospectively in these biobanks. But there's more research to be done.
Yeah. You've collected like 5 years plus of data, right? Is there anything that you would like to share with other clinicians on what you've learned the most, like what surprised you the most, anything that you thought was enlightening about using the test multiple times, and also comparing it to your pheno age?
Sure. Yeah. So we have in my practice and in other practices at License, we have a platform called PhysioAge, which takes all the data, the objective data that I collect on patients, and uploads it into the cloud, and then puts it into a sort of a health dashboard. And we've recently been able to take that for the whole Raphael Medical cohort over the past 20 years and upload it into Databricks, which is a way to analyze all this stuff. And we found that we have a lot of patients with very low glycan ages. And, initially that was surprising to me because, I'll just come out and say my first glycan age when I got it done was like 23 or 24. And I was, I guess, 61 or 2 at the time. And I was like, well, that's nice, but very skeptical, right? As anybody would be. Like, how can you be that much younger? And, when you tell, and then it wasn't just me. I had other of my patients who had been with me for, 2, 5, 10, 15 years coming in with significant glycan age acceleration. Let me just explain glycan age acceleration. You can use that for any biomarker. It's your marker's result in years minus your chronological age. So if your glycan age is 20 and your chronological age is 30, your glycan age acceleration is minus 10. And you want to be negative on that. So I have patients that are, minus 30, 40, 50 years. And that is very surprising, okay? Because you don't see that with a grim age or with other ones that predict chronological age a little bit better. And the question is, is that real? What does that mean? Well, what it doesn't mean, and I've emphasized it before, is that, I look pretty good for my age, but I don't look like I'm 20, 22 or 23 years old. So it doesn't mean that you are that biologically. But it does mean that, my glycan shield is 100%, my glycan youth is 100%, and my mature is 3%, which is what you would find in a 23 or 24-year-old. And so what we don't know is what is the long-term result of that. Does it, is it going to reduce my risk of cardiovascular disease, of autoimmune disease, of metabolic disease? We don't know that yet. But I think that it's probably a pretty good thing, particularly since it's stable. But there's a lot more research to be done. Now, and I would say that's true. It's not just glycanase. Like, I have patients that come in and we measure cardio age, which is a measure of your arterial stiffness, pulmo age, which is your FEV1, which is, so think of as your lung age. Everybody, as I said, is a mosaic. I have most patients have at least 30 years of difference between their youngest biomarker and their oldest biomarker, including all the molecular, cellular, epigenetic ones. And so we're all just a mosaic of things. And I have some patients come in with, on their initial evaluation with a glycan age of 20 years older, a glycan acceleration of 20, which is not good. And that's something then to focus on. So I think over the years, I was most surprised at how much of a delta there can be. Okay. But I think partly that's because in my population, there is people that they're highly motivated to keep their body composition in great shape. They're at usually ideal body composition. They have great exercise habits, stress reduction. They're doing everything right. And then their hormones are optimized. So that's why. And that's why I was surprised to hear when I was at the conference that you and I were at Deep D in Dubrovnik, that my practice has the lowest average glycan age of any of the 2,000 clinics that they work with.
Yeah.
But I think largely because I have a pretty mature practice where I have many patients that have been with me for 5, 10, 15, 20 years and have been optimized for that length of time. But we do see patients when they come in having maybe 5 to 8 years younger than average. Their glycan age is -5 to 8 in terms of their chronological age. So it's a healthier population that comes in. But it's not like the average, which is -15 or -25 for females and males in my practice. But once they're there for a while, we're doing all these things, it goes down. It's a minus per year of minus 1.5 and -2.2 or something like that for males. So if you do all the things that we do in longevity medicine, if you attend to all the aspects of aging, optimizing. So for instance, the glycan shield can be affected by reducing toxin burden, improving vitamin and nutrient levels. The mature is very hormone responsive. And so if you're attending to all those aspects of aging, and we haven't teased it out yet, we don't know exactly which ones are doing it, then you can see this in your patients. You can see this reduction in glycan age. And I would be extremely surprised if that doesn't end up being shown to be a very good thing over time with further studies.
So along those lines, how long do you wait to retest, right? Like, how long does it take to see the effect of, let's just say, TRT, HRT, or any other intervention that would move this manifest itself in the test itself?
Yeah, great question. And so because of that half-life of about 3 weeks or 21 days, you're going to get some signal at that point, but it's kind of like an A1C. Remember, if we all of a sudden put someone on GLP-1, they start losing lots of weight, their blood sugars come down, we're not going to see their A1C move much in a month. We'll see it move somewhat, a fraction of it, but we're not going to get the full change until that 120 days life of the red blood cell is completely turned over. And then we see what the new set point is. And so about 3 months is the earliest that you're going to see for like a hormone optimization thing, which is can have the most profound effect. I've seen glycan ages drop 10 years in a year of going from very little estrogen to very good estrogen therapeutic levels. Lifestyle changes, I think I see that taking a little bit longer because they're usually not as dramatic, although with the GLP-1s, they can be more dramatic. And then, a readout, as I said, after a year is sort of what your sort of long-term state is. But so I check it when I'm actively moving things. Not that often at 3 months, but sometimes if I've seen a big change in other markers like weight, blood sugar, hormone therapy, et cetera. And when in the first year that I'm actively adjusting the therapy of a patient, seeing them 4 times quarterly in the first year, I will sometimes do it after the first 3 months, almost always after the first 6 months. After that, as I'm tracking things, if it's steady, I'll do it yearly unless something changes. And so that's sort of the long-winded answer to your question.
Got it. And, I would be remiss if I didn't ask about peptides, which, we gotta ask about it. I mean, and we can probably infer what the effects might be, right, based on how glycosylation works and so on. But I'm curious, like in your population, now with decades of experience, is there any effect that you've seen particular peptides seem to have? And again, this is not clinical evidence or anything like that. This is just your own experience on glycan age.
So this is an easier question for me to answer because I don't use peptides a lot in my practice. I initially used BPC 157 for a bit, and I think it's probably relatively benign. I don't know. I've had some patients that feel like it's the best thing since sliced bread for their knee or their hip or whatever, but I'm just not convinced about the clinical trial data, which is almost, as you know, relatively non-existent. So I don't have a lot of patients that are on chronic long-term, as some of my colleagues have. To give you a real answer to that, you're right. Things like the growth hormone secretagogues.
Yeah, I was curious about those in particular. Mechanistically, you could.
No, I think that growth hormone is probably, and there's no direct data for that, but I think it may be a factor in it. Certainly, not certainly, but there's some evidence in some studies that it can help with thymic rejuvenation. The TRIM trial, previous study, Napolitano, showed some growth of the thymus. So if a peptide is doing that, and also these are also lipolytic, tesamorelin Agrifta is approved for getting rid of fat, and having visceral fat is not a good thing. And there's great studies showing that growth hormone can reduce visceral fat quite significantly after 9 months therapy. So I would not be surprised if if my colleagues are seeing a signal like that. The other ones, the ones that affect the immune system, I don't use them, so I can't give you an answer.
So maybe there's 2 questions here I think that maybe we haven't touched on. So one of them, so glycans move much faster than most aging processes can be modified. This is why I'm not entirely convinced that we can regard them as a true aging marker rather than an indicator of the immune profile. Could you elaborate your thoughts on this?
I mean, that's an interesting perspective, but I'd push back on that and say, you can say the same thing about hemoglobin A1C. It moves pretty fast, 3 months or so, 4 months. If you profoundly change your average glucose level by whatever you're doing, and there is long-term data that maintaining that hemoglobin A1C in that range lowers your risk of all the complications of diabetes. We don't have that long-term data for lowering glycan age, so I understand the skepticism there, but the parallelism is almost exactly the same, and so I wouldn't level that as that's a good thing, really, as far as I'm concerned. The problem with the methylation clocks is that I don't really know what moves them. My friend and colleague Cara Fitzgerald was able to move it by 3 years with a diet of a Mediterranean diet and some supplements, but 3 years is a reasonable number. But there's bigger changes. If we're getting a bigger change like this, the real question is, and that's where the long-term data is going to be helpful, is does that result in the same thing that a big change in lowering hemoglobin A1C does? That's the open question. But I think practices like mine that collect data regularly are going to accumulate a database of this sort of thing, and hopefully over time we'll be able to report that out, and I have to wait for the large randomized controlled trial that looks at this. But those trials should be done, and I think that I think that they will probably show that doing this really does help quite a bit.
Right. That's the other question that I think is probably a lot of people are wondering. So I often see elevated glycan age in entrepreneurs and founders. So we, stressed out people. How do you approach this when the rest of the blood work looks stellar with no apparent intervention points? Most of these individuals typically can't slow down due to their workload. This is a common, I think we've learned even just anecdotally from these glycan age tests that stress, and particularly emotional stress, does move the glycan age test, the Inflammaging, but it's just a harder thing to quantify.
So this is these people have bad glycan ages, but the rest of their lab work looks good, but they are under high stress. Okay, this is where looking at the different subspecies can help you. If the glycan mature is high, then they probably have a hormone issue. And if you're under high stress, you're a male, that does, and particularly if you have some visceral, is their number stellar on their visceral fat? That depends. What do you mean by stellar? 7 or 8 is not stellar. You can still have some insulin resistance with 7 or 8. 5, 4, 3, that's stellar. So, this way you can start to tease out what might be doing it. If they have a very low glycan mature, so it's not really a hormone issue, but their shield is low, then I would maybe look to see if they have toxin burden. I recently had a high net worth individual who was really healthy on all that sort of stuff, have a high glycan age. I did her total tox burden. She had a lot of mold and a lot of pesticides from, her multiple estates that she goes to. So, that sort of thing. But the straight up stress can do it as well. The real challenge then is, how do we get these people to slow down? Sometimes, and that's where the glycan age test could come in very useful as a behavior modifying tool. It's like, if you don't slow down, you're going to maintain this high glycan age. And, I can't say right now with the data that you're necessarily going to have an adverse outcome, but it's not going to probably be as good as if it's your chronological age or lower. And so maybe it's time for you to start thinking about it. Just as patients to come in and get, they're healthy and they're exercising but they're not watching their diet, their LDL is high. You get a coronary calcium score on them, or better yet, a CT angiogram, and you show them that they've got significant plaque, then they're like, okay, I need to start modifying my diet. This could be the information that's necessary. Everything else looks good, but you're still reading out as having a high pattern of IgG glycosylation that is giving you a high glycan age. It's not your hormones. You got to cut back on the 20-hour work days and the chronic insomnia, sleep deprivation. And so that's another way that it could be used. But really look at each of the 3 different readouts. And the mature is the one that is really very hormone sensitive. And this guy, or even a female, maybe she's on hormone replacement therapy, but it's low dose hormone replacement therapy. The symptoms are gone, but her free estradiol is just not high enough to bring down her. And that's often a thing that we see a lot, like because of the whole insistence on symptoms only, lowest dose, because of worry about breast cancer. I think that there's a level, and it's usually a little higher in women in my experience, that is needed to drive the mature down to a level where the glycan age comes down to where it should be. The reference population is an average population. They're not exercising a whole lot. They're probably modestly overweight. My patients that come in that are doing all the right things, they're usually 5 to 10 years younger. And so if they're not at that point, then they probably don't have optimal hormone levels. So that's an area to look at.
Do you feel like you have enough experience at this point to see if there are any ethnic differences with how glycan age behaves or responds?
I would say the answer to that is no. I have a largely Caucasian population. I have patients from all over the world, various different, but it's not a large enough population to necessarily see that. I have seen that in telomere length, and that's borne out by the literature, that some populations have shorter telomeres than others. And that's largely because of the level of, I think, cytomegalovirus and other things, some genetic components to it. And, I think Gordon Louse might have a better answer to that, and Nina, the CEO of Glycan, but I can't see it in my practice yet.
I mean, just zooming out, like from a first principles perspective, like when I first heard about this connection between hormone replacement therapy and glycan age, which if we take that to be a proxy for inflammation, I was initially kind of surprised by that, because we typically think of hormone replacement therapy, testosterone, estrogen as being things that, and again, this is a very coarse description, right? But like, these are things that generally are going to promote kind of cell growth, like kind of, proliferate, not proliferation in a negative sense necessarily, but just, this is not a kind of cell maintenance or cell turnover or like autophagy inducing type thing, right? So,
suppressor, yeah.
Exactly. And so we're typically, when we're reducing inflammation, we're typically often thinking about things like that will act on those pathways, right? And so I was kind of surprised by this connection. I'm curious, like, do we have any further insight into how, like within, let's just say, testosterone biology or estrogen biology, like what's happening downstream of that receptor that might be resulting in this anti-inflammatory effect?
Well, let me answer that part directly, and I want to step back just about immune aging in general. I alluded to it earlier, maybe quickly, but there is reasonable evidence that the enzymes that regulate that glycosylation of the galactosylation in particular are under estrogen control. And so that's a direct link. And that's, there are studies that show that testosterone replacement therapy lowers glycan age almost exclusively through its conversion to estradiol. There's a study that looked at dropping testosterone with a drug, goserelin, that stops testosterone production, and then replacing testosterone, and testosterone then got rid of the drop in glycan age, the increase in glycan. There wasn't glycan age, it was glycan species that were inflammatory. But if you gave an aromatase inhibitor so that testosterone couldn't be aromatized into estradiol, that wiped out that beneficial effect. So then it stayed down. So its effect is through estradiol, and males and females pretty much need about the same level of estradiol to maintain their physiology. Testosterone is much higher in men, and estrogen is higher in females. But so the free estradiol is pretty close in postmenopausal hormone therapy and in males getting testosterone replacement therapy. So that's the direct kind of control of it. But that's really just for the IgG glycosylation, which is only one aspect of the immune system. So I think a very important one. But the other things that you mentioned, autophagy, more important for T cell function, very important for T cell function. And do hormones affect that? I mean, I don't know that we have any significant data for that yet. There's many other things that affect it. The innate immune system's function controls inflammation to a certain extent. But I think that you want to step back a little bit and say that also, and think differently about hormones going forward, which is they aren't just about that sort of thing. They are profound effectors of the immune system. Particularly estradiol has, receptors on every cell in the body. And they're not just nuclear receptors. There's cell surface receptors, or the ways in which they affect the caveolae. There's a whole bunch of other ways in which estrogen can work more quickly than through nuclear receptors and transcription. So estrogen is hugely important in every aspect of physiology, really. And we see it, in everything we do. And I think more and more we're seeing it. So I think I get why you had that initial surprise, but I think that, and again, I think it's not affecting necessarily those other things like increase in senescent T cells, decreased function. I don't think it has that much effect on thymus. So, the testosterone does. I mean, androgens kind of cause the beginning of thymic involution. So there's a whole other question there, what to do about that aspect of it. So, I think there's just so much more research to be done that, we need to start thinking about these molecules and there's a whole movement within menopause and ovarian aging to not call them reproductive hormones, but to call them, system-wide regulators. The ovary is not a sexual organ. It is a major endocrine organ that regulates many aspects of physiology.
Yeah. Well, to that, Joe, if you want to leave us, maybe our audience, with one, or what would you like to leave? What kind of messaging, if you could leave clinicians with something about inflammaging and modifying the aging trajectory that they should take away to their practice, and all the experience you've had and what you've learned, what would it be?
Well, first thing I'd say about inflammation is that it's not about suppressing inflammation. You want your immune system to be effective and smart. You want it to be able to respond quickly, but then briskly respond to a wide range of antigens, and then also to stop responding and resolve that inflammation. So that's what we want to do. But that's a very tricky process, and it happens at multiple different levels. So, I think that, and I mentioned earlier, or maybe I didn't, but I really think of the immune system as the queen system, because it kind of affects inflammation and affects multiple organ system. And so querying and monitoring the immune system from multiple different angles, I think will give you a really good idea about how to control the aging of your patient's physiology and their susceptibility to disease. So look at it from the glycan age standpoint, look at it from the lymphocyte subset standpoint, from the senescent cell standpoint. I use Sapir Bio for that. There's many different aspects to look at it, and those would be the levers that, as we move forward with precision medicine, that we're going to get better and better at adjusting to keep people with the most youthful immune system, which is the smart, diverse, and quickly resolving immune system that you have when you're young, as opposed to the immune system that's noisy and chronic as you're older. And I think glycan age and monitoring your IG glycosylation can help see one aspect, and a very important aspect of that. And we have really great tools for reducing it, particularly through the mature species and hormone therapy, but also through weight loss and stress reduction, et cetera. So, like they say, mind the gap, mind your immune system from many different systems and from many different perspectives. And I think, the glycan age test is one that, if you're in a longevity practice, that it's really, I find it to be very useful, particularly if you're doing hormone optimization, and want to also to help tell people about whether they're exercising correctly and whether their weight loss journey is working. I think it's a great biomarker of things that that can help us change our decisions and help our patients age better.
Great.
Awesome. Well, on that note, thank you so much, Joseph, for coming to speak with us. This was such an amazing conversation. I think your expertise and insight really shone through. I think we both feel lucky to know you as a colleague, and I'm sure those of folks listening, I think we're really excited and blessed to hear everything you just had to say. So that was really awesome. Thank you so much for joining us. And again, quick plug for our conference. If you like conversations like this one, you should be at our conference in Osaka in October. Website to apply is nextgenerationlongevity.com. Applications are still open. If you are listening to this on LinkedIn, there's a good chance you should be joining us, or any other social media channel for that matter. I know we're live on a couple of others. But all that said, thank you so much, Joseph, for speaking with us. And Deepthi, thank you so much for helping to set this up.
Great. Thanks very much.
All right, guys.